This is Unit 3, Triangles. Preview video 3.5, Congruent Triangles. Sit tall. Take a deep breath. Ready? Inhale. Hold your breath. Your eyes should be closed. Slowly exhale. Keep your eyes closed for a few more seconds. Take a deep breath. All right, I promise you this is one of the easiest lessons of the entire year. Don't forget date, time, location, as well as a sign-off. Taking a look here, you are told that in this triangle, XYZ, that AB is a mid-segment. You're going to use that concept to find the value of X. Things before algebra, do this on your own. Restart the video when you're done. All right, your thing equation should have, restart, obviously you should have a red pen in your hand. Your thing equation should have looked something like this right here. 2 of AB, that would be 2 of these, equals XZ. Takes 2 of AB's equal XZ. So you solve, we have 2 of 3x minus 1 equals 34. Distribute. Students, if all you're doing is copying and not correcting right now, you're really losing out on a learning experience. When I ask you to pause and do your own work, even if you get this incorrect, the act of correcting incorrect work is more of a learning experience than simply copying the answers. So please make it a habit. When I say pause and do your own work, actually do that, friends. So X is 6. And you should have checked it. 3 times 6 is 18 minus 1 would give you 17. And 17, you check, is half of 34. Ta-da, good job. Taking a look here. We got a lot of new vocabulary here. So let's just take a moment and read these out loud. Check them. Slide, flip, turn. Translation, reflection, rotation, congruent, Cpctc, pre-image, image, corresponding, whole part. A lot of new vocabulary for something that's actually quite simplistic. So we take here, and all we're doing is we're taking this triangle, the same triangle, and we're sliding it left to right. Slide. The original triangle is called the pre-image, and after you slide it, the after image is called the image. Pre-image, image, after the motion. This motion of sliding is called translation. Now, imagine a mirror here, and you're taking an image and you're flipping it over completely. Flipping it over. Flip. This flip motion, flipping over, if you will, or a mirrored image, that's called a reflection. And the image, and then you flip it over, and that's called the pre-image. Last, imagine there being a pivot here, and you take that image and you simply turn it. You spin it. Turn. When you turn something, That's called rotation. All righty, friends. You're going to get out of your seats. You're going to totally do this with me. Yes, you are. Ready? Put your hand in front of you. Go like this. Translation. Reflection. Rotation. Translation, reflection, rotation. Those are 3 motions that we are learning. I dare you to turn those motions into a dance move for the fall ball. So your 3 motions are slide, flip, and turn. They are translation, reflection, like a butterfly, rotation, slide, flip, turn. Take a moment, take 10 seconds, and I'd like you to draw a translation of R, a reflection of R, and a rotation of R. 10 seconds. Lickety split. Go. Ready? A translation, if I were to just slide R over, it'd be the exact same image. Reflection. Think of it as a mirrored image. And then rotation, if you were to rotate this, I didn't really tell you how much to rotate. If you were to rotate 90 degrees, it would look like that. If you were to rotate 180, be like that, but some sort of rotation. You zoom through this page and determine what motion is being used. Translation, reflection, or rotation. Go. Pause the video. Once again, students, you are correcting your work with a red pen. You are not copying. This should have been easy, pretty easy. Yes, this is right here, of course, a reflection. This is a rotation. This was also a reflection. Down here, number 4 is a translation. This was a reflection. And of course, this is a translation. Okay, now that you have those 3 motions, how are they related to triangles? Because everything we do in this unit is relating to triangles. So I want you to look at the triangle from the left to the right. And first, you're going to identify what is the motion from left to right. 10 seconds, write it down. Okay, you should have gotten rotation. This is a rotation, and it is a counterclockwise rotation. We rotate it that way so you can see how D matches with T. So we have a rotation. And what's really a simple concept here is if you take any triangle and you put it through any one of these 3 what are called rigid motion, translation, reflection, rotation, you get corresponding congruent triangles. This, my friends, is not terribly complex. This is what I mean. If I take that yellow triangle and I translate it, rotate it, reflect it, this orange triangle is going to be exactly congruent to it. And when full triangles are congruent, get used to doing this. Go put your hands up, put your fingers together, repeat after me. Say the whole thing's congruent. Now go like this with your fingers. Say all the parts are congruent. Do it again, put your fingers together. Say if the whole thing's congruent, the parts are congruent. And what we mean by that is if I say the entire whole triangles are congruent, which we just established, then I can say this. Angle B is congruent to angle R. Angle C, notice the double sweep, and angle S are congruent. D is congruent to angle T. Now, careful, B to C. Notice the direction I'm going. B to C, red to blue, is congruent R to S. I'm going from single to double, R to S. Friends, watch out. If I say side BC and I want its matching corresponding side, you may not say SR here, because B corresponds to R and C corresponds to S. So you must follow that same order, R, S. Knowing that, let's finish the rest. CD, we're going from double to triple, is S to T, double to triple. Last one, DB, triple back to single, is TR, of course, triple back to single. Note, when you are told that you have congruent triangles, there are 6 items, 6 pairs of items, 3 sets of angles, 3 sets of sides, 3 sets of sides. So when you are told the whole triangles are congruent, all the corresponding parts are congruent, there's 6 pairs of things congruent. 3 pairs of sides matching, 3 pairs of angles matching. You must correspond the congruent vertices. First off, you're going to ask yourself, what is the motion from left to right? So going this way, what is that motion? So I like to check reflection first. It's easy. So just take the image and go kind of like this with your hands and ask, if I were to fold this, would it match? And if you were to fold along ML, no, they would not match. So it's not reflection. Translation, it's the exact same image left to right. It's not translation. So watch very carefully. We have triple here and we have triple down here. Okay, which means this is a rotation. We rotated clockwise. Okay, the triple went that way, then the single rotated this way, and the double went up this way. So we all rotated. So it is rotation. Now, watch carefully the order here. MLW. Okay, we are working with this triangle on the left. So watch the order here. M, single. L, double. W, triple. Single, double, triple, and therefore its match has to be single, double, triple on the other side. So single on the right would be L, double would be M, triple would be N. So single, double, triple. So it would be triangle L, M, N would be the congruent triangle. So in the diagram below, what's the motion of left to right? I generally check for reflection first. You know it's not translation, because translation just means to slide. You get the exact same image. This one, you go like this with your hands, fold it. If you were to fold along that yellow line, you see E would match. E would match with P. If you were to fold, this Q would match with that Q. And then this R would match with this R. So now you know, yes, you can fold it, so it has to be a reflection. So R, E, Q. That's the left-hand side here. REQ, single, triple, double, must match RPQ, single. Oh, wait a minute. Hang on. RQE. I got that backwards. Let me do this. RQE. RQE. I didn't put my finger on the paper. RQE is like this. It's single, double, triple. Therefore, you must go single, double, triple, which would be RQP this way. Single matches with single, double matches with double, triple matches with triple. Single, double, triple. Now we get to this you had an acronym earlier, Cpctc. Something sounds super complicated. Let me give you the complicated version, and then as usual, I will give you the simplistic version. Cpctc stands for corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. What does that mean? Corresponding parts of congruent triangles. So if I have triangles which are congruent, every corresponding part is congruent. This angle would be congruent to this angle. This angle would be congruent to that angle. This angle is congruent to that angle, etc. So basically what it means is, put your fingers together like this, repeat after me, say, if the whole is equal, the parts are equal. If the whole is equal, the parts are equal. It goes back to this. Ready? Look carefully. What is the motion of left to right? You check for reflection. I go like this, and I ask myself, if I were to fold this, would those corners match? First off, you see if it's a slide, left to right. No, it's not exactly the same because these change. Now, if I fold that, they don't match because I got a double and a triple. This is a rotation. And we rotated this triple up this way, this goes this way, and that went down. So this is a rotation. S-T-R. S-T-R. Triangle. S-T-R. Notice the order. Single, double, triple is going to match on the right-hand side, single, double, triple, which would be V-R-X. You do these two on your own. Pause the video. Restart when you're done. Students, you should have a red pen now and you're correcting your work. You should have worked in pencil, correct in red. So what is the motion left to right? For this, watch for it. It's not reflection. You can't fold it. It is rotation. Because if you look carefully, this rotated upward, the double went this way, and then the triple moved that way. So we know that this is rotation. P-Q-R. On the left, P-Q-R. Single, double, triple on the right-hand side. Our single would be I. Our double would be H. Our triple would be R. Single, double, triple. Coming over here, Checking for reflection. If I fold over BA, would they match? The answer is no. So we know it's also not a slide. We know that this is a rotation as well. The triple went all the way around like this. The single rotated clockwise. So ABC, A, B, C, single, double, triple, matches single, which would be B, double, which would be A, triple, which would be I. Now the question comes in, how do you know things are congruent? To begin with, everything we've done so far, things have been marked for you congruent. Are there any other ways things can be congruent? There's actually three sources of congruency, what are commonly called freebies. That's a technical term invented by Miss Way, which means things that are always congruent but not marked, versus here they're marked. Things that are always congruent but they're not marked. So you have to spot them and mark them. And they are now, I just marked them, but now I'm going to explain them. Vertical angles. Anytime you have two straight lines, the angles directly across from each other are vertical and therefore congruent. Get in the habit, starting now, whenever you mark things congruent because of a freebie, mark A for a pair of angles and S for a pair of sides. So here I have a pair of angles. I'm just going to put an A, a circle around it. You're like, what's that about, Miss Way? You'll find out next lesson. A reflexive side is when you have a segment that is exactly shared, like an apartment wall, shared between two distinct triangles. So that red segment right down the middle is shared by the blue triangle and the orange triangle. We call that reflexive. It's reflexively shared by two triangles. So technically, because it's shared by two distinct triangles, the same wall, we would call that still a pair of sides. So S for a pair of sides. Coming over here, I'd like you to trace this smaller triangle. Just trace it. Now trace the larger triangle. Trace it just a couple times. You should feel that both those triangles exactly share and overlap at that one upper angle. That's called a reflexive angle. Just like this is a reflexive side, shared. This is a reflexive angle, shared. A for angles. Technically, there's a pair of them. So we're going to mark the freebies, things that are congruent but not marked. So in this diagram, these angles are pre-marked. But this side is not, but it is freebie. It's a reflexive side. Hatch mark it. S, we have a pair of sides. Small triangle, larger triangle, they exactly overlap and share what I will call this toe angle here. That's called a reflexive angle. These are vertical angles, of course. Another pair of angles, A for a pair of angles. This one, you're going to mark all the freebies. A for angles, S for sides. Do this on your own. Pause. Pause. Welcome back. Red pen's handy. Let's check your work. You're looking for your freebies, and we're going to mark them. Ready? That's a reflexive pair of sides. Hatch mark, S. This is also a reflexive pair of sides. Hatch mark. Technically, it's the second set in the same diagram, so I'm going to do 2. S for a pair of sides. Here, both those triangles overlap and share H, so that's a reflexive pair of angles, A. Down here, I have a pair of vertical angles and a pair of angles for A. Down here, these two triangles, let me overlap them here. You can see them. They both share this angle right there. Hatch mark, A for a pair of angles. Summarize what you have learned in today's lesson.